All right, the next lesson in this chapter is volume of rectangular prisms. When we talk about volume, we're talking about filling up an object. So volume is really talking about filling. And when you're filling it up, you're trying to figure out how many cubic units go into it. So remember back in elementary school, you had those little counting cubes. Basically, you can kind of think about it as, all right, we have an object and we're filling it with those cubes. So you're filling it with those cubes, which reminds you that your units are going to be cubic units. So inches cubed, feet cubed, miles cubed, whatever your units actually are. On your formula sheet down in the bottom right corner, there's two 3D objects. The one on the top is the rectangular prism. Rectangular prisms have length, width, and height. Today we're focusing on volume, so we're using the V equals formula. Capital V equals length times width times height. So all we need to do is figure out what the length, width, and height are and then multiply them. So on this picture right here, example 1, this would go with the length, this would be the width, and that would be the height. So the length is 5, width is 4, height is 3. Write my formula, LWH, plug in 5 times 4 times 3, and you're going to get 60 centimeters cubed. So inside this rectangular prism, you can imagine 60 of those little squares would actually, 60 of those little cubes would actually fit inside of it. In example number 2, we have two lunch boxes here. Both are rectangular prisms, and we want to know which one holds more food. So we're filling it with food, we're finding volume. So we're going to do the volume of lunchbox A, and then we'll do the volume of lunchbox B. Since they're both rectangular prisms, it's both LWH for them. Looking at my picture, this would go to my L, that would be my W, and that would be my H, my L, my W, and my H again. So for A, I have 7.5 times 3.75 times 10. I use my calculator, and I get 281.25 cubic inches. For B, my length is 8, my width is 3.75, and my height is 9.5. And we get 285 cubic inches, which tells me this one has a higher volume, which means it would hold more food. So B holds more food. Pause for a second, and I want you to do example 3 on your own. It wants to know what's the volume of the aquarium. So you did length times width times height, so 24 times 12 times 14, and you got 4,032 cubic inches. In example 4, a toy company makes a rectangular sandboxes that measure 6 feet by 5 feet by 1.2 feet. Whenever you see these written out, this is length by width by height. Customer buys a sandbox and 40 cubic feet of sand. Did the customer buy too much or too little sand? So let's figure out, if we were to fill this up, the sandbox up, we're doing 6 times 5 times 1.2. And if we multiply 30 times 6 times 5 times 1.2, we get 36 cubic feet. So even if we filled the sandbox all the way to the top, we'd only need 36 cubic feet of sand. The customer bought 40 cubic feet of sand, which means the customer bought too much. In the next example, we have an office here. So here's my length, my width, and my height. It says it costs about 11 cents per year to air condition 1 cubic foot of space. On average, how much does it cost to air condition the office for 1 month? So air conditioning is going to fill the room, which means we're talking about volume. So length times width times height. So 32 times 25 times 12, which gives you 9,600 cubic feet. It says it costs about 11 cents per year for 1 cubic foot. we have 9,600, so we're going to multiply by 11 cents. That's going to give us $1,056 then per year, because it's for 1 year. However, the question says how much does it cost to air condition the office for 1 month? So in 1 year there are 12 months, so we need to take this and divide by 12, which gives us a cost of $88 per